and the level of water was the moment for which we needed the GM, virtual GM. For at that time, through that discussion, what did we finally get? Did we get the ship's hydrostatic draft at that time? Did we get the after draft? Did we get the forward draft? Which draft did we get? For which we had to calculate. No, for which we had to calculate, I'm asking. The moment for which the question was required, at that time, what did we know? Did we know the high draft of that particular moment initially when we were discussing, or did we know the after draft, or did we know the forward draft? What did we know? So we know the aft draft. Very good. So we knew the aft draft, correct? So whichever draft we knew, we will find out the draft at that very point at the time of critical instant, right? Yes, sir. Yes, sir. And then we'll compare the draft after critical instant with the draft of 5 meters to make an inference whether the ship is within the critical period or outside it. Is it clear now, Anubhav? Clear, sir, clear. Okay, fine. Any more doubts, guys? See, this is what happens when people, this 5 minutes of grace window, people want to postpone the commencement time. If they were struggling with the link, then they should have raised the alarm at 9:25. At 9:37, 9:38, after plugging in late, now they are sending SOS messages. And this is exactly what I was trying to say on the first day. That do not assume that the starting time has been pushed out. Starting time remains 9:30. Everybody requested to join by 9:25. 5 minutes extra of waiting was only to accommodate last minute issues with somebody. It is not that people wake up at 9:35 and start plugging in and then say, we are not able to join. So anyway, who's coming now? Dheeraj has come in. Somebody has just joined in. Who's that? Yes, sir, already joined. Yeah, so then why don't you join in time, Dheeraj? Why you keep sleeping till late, man? Okay.
No, sir, I was trying since 9:27, I was trying. But finally, after till 9:35, I could not. Then I messaged.
Okay. Okay, guys. Now, I had requested you to find out in question number 4, is the vessel within the critical period or not when the level falls to 4 meters? Tell me. So vessel is outside the critical period. Okay. Because the draft at critical instant is 4.374. Very good. So I'll also show it, but before I show it, if anybody has faced any difficulties, that is a better way of learning. Rather than seeing the solution and then trying to figure out what mistake you made. If you faced any problems, let me know. I will try to understand where are you facing the issues. None? Okay. So guys, again, the same questions you'll be asking yourself. It says, MV Inship enters seawater dry dock drawing 3.6 and 5.6 kg 7 meters FSM 900. Find the virtual GM after the water level has fallen to 4 meters above the blocks. So in question number 3, he had given the depth in an indirect way. There he said 1 meter after the stern has touched the blocks. Here he has directly given you the depth. So see, the same information can be presented in different forms. So that is what you must be open to. That there also he was giving you depth, but not directly through an indirect information route, and here he's given you directly. Now, so then I'm asking myself, which is the first point of contact, and these are the questions you will ask yourself when you're solving. Which is the first point of contact? Stern. Why? She is trimmed by stern. At what depth will the stern make first contact? At 5.6 meters. These are the questions you will keep asking yourself. Then, After 5.6 meters depth, the draft aft and the depth will change together because the contact is made. So that means when the depth, when the level falls to 4 meters, what I can say with surety is that the draft aft is 4 meters. So now we'll find out draft aft at critical instant, compare it with draft aft of 4 meters, and make an inference whether the vessel is within the critical period or outside it. Will you be able to talk to yourself like this and reach? This will just take 10 to 15 seconds, guys. It's not going to take 2 minutes. Have you understood how to figure out? Clear? Yes, sir. Okay. So we'll first get the hydrostatic draft. We get it 4.580. You can keep telling the milestone, each milestone, you can tell you the result. Now, which particulars to interpolate? Same particulars which were required in question number 3. W, TPC, LCF, and MCTC. And we'll interpolate them. Why am I interpolating TPC? We used in the last result, so I'm hoping that it may be used in this question. If it is not used, no issues. But be prepared that TPC may be required to be used like we used in question number 3. So just to avoid the need of going back to the tables if TPC is required, you can interpolate TPC and get the values. I'm sure all of you would have got these values, right, guys? Correct? Correct, sir. Yes, sir. Next, we will find out P at critical instant because we have to find draft at critical instant aft. So P at critical instant is 448.3 tons, correct? It's on display. Am I right? Correct. Yes, sir. Correct. Yes, then we get W minus P and we get a draft of 4.375, right? Yes, this 4.375 in the table is the high draft. This is the high draft at critical instant. Now, since the vessel is on even keel, the trim is 0 at critical instant in this case. Therefore, draft aft shall also be 4.375. What is our draft for when we question is to be calculated? It is 4 meters aft. So that means the vessel will basically reach critical instant at a depth of 4.375 meters. Therefore, when the level drops any further to 4 meters, she is happily sitting on the blocks completely. Does everybody agree with it?
Yes, sir.
Yes, sir. Okay. So, up to this time, the process was same as question number 3. But here the results are opposite to what you got in question number 3. In question number 3, you got the vessel within the critical period. In this one, you are getting the vessel outside the critical period. Now, when the vessel is sitting overall, better mute kar lo, please. Mute kar lo, bhai, please. Now, if the vessel is made contact everywhere, so what have I been saying? Wherever the contact is made, the depth and draft at that point will be same. So now the forward is also sitting on the blocks. So that means what will be the draft forward? The draft forward will also be 4 meters. Am I right, guys? Yes or no? Correct, sir. Correct, sir. Correct. Yes, sir. Right? Yes, sir. So the vessel will be sitting at 4 meters on even keel condition. So the vessel would be sitting somewhat like this. Here are the blocks. And now the ship is sitting here on the blocks on even keel. And the depth of the water is now 4 meters. At this point in time, you can get to know the buoyancy support. Why? Because this is the volume of water displaced. And if this is multiplied by density of the water will become the buoyancy. And that will be equal to displacement at 4 meters. Am I right, Vita? Yes or no? Displacement at 4 meters will be the buoyancy support to the vessel. Please let me know if you have any problems in comprehending it. Please let me know, class. The displacement at 4 meters picked up from the hydrostatic tables will be the buoyancy support available to the ship at that time? Yes or no? Am I right?
Yes, sir. Yes, sir. Correct. Because of the draft is there, 4 meters.
Yes. So whatever displacement will be there. Now that is not the ship's displacement, mind you, but we are using that displacement to get the buoyancy support. And we know the displacement of the ship. Now, when we say displacement of the ship, in dry docking, there will be only one displacement, and that is the actual displacement of the ship. W will be used only for the ship's displacement. If you have to find this displacement, actually this will be W minus P, but if you don't agree that it's W minus P, you can write it like this. But only W will be the displacement of the ship. Am I clear, beta? Is that clear? Is that clear? Right, guys? Yes. So you
Yes,
know the displacement of the ship. You got it against the height draft of the ship. You know the buoyancy support, which will be displacement at 4 meters. When I subtract from the displacement of the ship the displacement at 4 meters, will I get P? Yes or no? Because the other method of getting P was W minus B. Yes or no? There were two methods of getting P. One, change of trim, and another, W minus B. Do you remember that yesterday's discussion, guys?
Yes, sir.
Yes, sir.
Yes, sir.
I give you 10 seconds to absorb it. Let me know if you have missed out something.
So we will subtract displacement minus
No,
displacement at 4.
tell me what is, no, I don't teach like this. We will do like this. Tell me what I have said. Is it making sense? Yes or no?
Yes, sir.
If it is making sense, then we'll do it like this.
Displacement at 4
I
meters.
don't support you in mugging up issues. If there is any requirement of mugging up, I'll just say mug it up here. Because let's not waste time in learning it. But when you see sense, then why are you wanting me to make a generic rule and say this is this? No, this is your basic problem, beta. You want to learn everything like this. So tell me, what is the doubt? Do you agree with this that it will be the upthrust? Yes or no?
Correct, sir. It will be upthrust 1259.1.
Owner, correct?
Yes, sir.
So, yeah,
Sir,
tell me what is the
again,
tell me the doubt. No problem.
4.375 pe, she sat on the blocks completely, sir.
So if you keep dropping the water level further, will she run
Yes.
take off from the blocks or will she keep
No,
sitting?
no, she will not take it. But the buoyancy है सर, अगर 4 मीटर से नीचे हो गया तो उसको कौन सा buoyancy लगेगा? पानी तो नीचे हो गया सर सारा.
किसके नीचे हो गया?
मतलब the water has gone down. ना, she is sitting on the blocks, assuming there is.
So she
मतलब
and how much of it is submerged in the water? How much water is she displacing at 4 meters draft? How much water is she displacing at 4 meters draft?
So she will not displace any water. Na? She is already sitting on the blocks.
Wow, wow, wow. If in a bucket, if you put a stone which goes and sits at the bottom, it will not displace any water. In a bucket, if you put a stone which goes and touches the bottom of the bucket, will it not displace water? The level of the, it will not displace water. Is that what you're trying to say? Then everything has to displace, unless it is in vacuum, it has to displace the medium in which it exists. You and me are displacing the air in which we are sitting. And if the ship 4 meter of it is submerged in the water, will that not displace the water?
Okay, sir. Sir, I was thinking that she is sitting on the blocks and.
No, so she is sitting. She is some part of the ship submerged in the water. Yes or no? She is
Yes.
very much sitting. It is not that you are thinking. You are thinking correctly. She is sitting on the blocks. Is the now the stone is sitting on the bottom of the bucket? Is the stone displacing water? Yes or no? Tell me that.
Yes. Yes, sir. Yes.
So just sitting at the bottom or sitting on the blocks and ship is not displacing water if it is if some part of it is submerged in the water, beta? Tell me, Inder.
Yes, sir. She is displaced. Yes, sir. ठीक है, sir.
How much? What to what? Answer my question. No. To what draft is the vessel submerged in water? 4 meters. Yes or
4
no?
meters. Yes, sir. She
So
is submerged.
that means that much water it will displace. No. Am
Yes,
I
sir.
right?
Yes, sir. ठीक है, sir.
So guys will get P differently this time. You see, that is why it was important to figure out whether the ship is within the critical period or outside. The approach has completely changed. I'll show you the thing. Don't worry. I'm trying to make you understand here. Now, once you get P, getting the virtual GM is not an issue. You know the last step. Km for W minus P minus kg. GM solid. Now the problem, now once the ship sits all over, does she have the risk of tilting sideways? Once she is outside the critical period, does she have the risk of tilting sideways?
No.
If she does not have the risk of tilting sideways, does the slack tank cause any problem? The free surfaces will pose any problem?
Negative, sir.
Free surfaces pose a problem when the ship inclines, correct? Otherwise, there are no problems, right? Am I correct?
Sir. While she says no problem.
So yeah, so when she does not incline and there is no risk of inclination, that means when there is no risk of inclination, the free surface becomes not applicable. I'm not saying free surface has become zero. Please be very clear in what I'm saying. And each word I'm speaking has a meaning. So you have to understand the correct meaning in the context of discussion. I'm not saying free surface effect has become zero. Free surface has become zero. I'm not saying free surface has become zero. Why? Because tanks are still in the same condition with which she entered. But now she cannot tilt sideways and hence the liquid will not shift. So free surface effect has become not applicable. So then see guys, free surface, does it exist? Yes, it exists. I'm not saying it does not exist. So don't say it has disappeared. FSC, is it applicable? It is not applicable. Why? Because the ship cannot incline sideways. Have you understood the difference between the two statements I've written, guys? Understood?
Yes, sir.
Okay. Yes. So now I'll take you through the solution. You know it. This is only for explanation. We have done it yesterday. The hydrostatic draft of the vessel when the water level falls 4 meters above the block shall be 4 meters. Why? Because she is sitting on even keel. So hydrostatic draft will be same as 4 meters. So we get this displacement. This is displacement at 4 meters, you see. Or don't write only displacement, or you can write W minus P because your P is nothing but displacement minus displacement at 4 meters. This implies displacement at 4 meters is nothing but W minus P. Correct, beta? Am I right? And that is why this W minus P has been used here. Correct, beta? Understood?
Yes, sir.
And yes, we'll need the Km for W minus P. So might as well, when go to the hydrostatic particulars, get the Km also. At 4 meters, the displacement of the ship, which will be the buoyancy support, is 7605, which is W minus P. And Km is 9.864. So we get the P of the vessel, that is, don't use the word initial displacement, just use the word displacement of the ship and displacement at 4 meters, okay? There is nothing like initial displacement. Displacement of the ship does not actually change. It's a virtual change which is taking place, right? So just ignore this word here. It's W minus W at 4 meters. So 1261.3 tons is the P here. And when you subtract 1261.3 from 886.3, you'll again get 7605, which is W minus P. And once you get the Km, then you are good to get the final answer. Km for W minus P, kg 7 meters, GM solid 2.864. Don't remove free surface from the table. Don't remove it. Free surface 0. In remarks, I have put FSC not applicable as the vessel is sitting on the blocks overall. GM fluid same as 2.864. Virtual loss P into kg upon W minus P, and we get the virtual GM of 1.703. Please have a good look at this question. Do it by yourself. Let me know if anything is still not clicking with you. I give you another 2 minutes now to absorb this, understand this. Hold your doubts for 2 minutes so that others are not distracted. 2 minutes down the line, I'll ask you if there are any doubts and I'll address them. Since you had already done up to that point, so this is the last part you have to do, that's all.
सर एक बार इसकी दो पहले की स्लाइड दिखा देंगे सर वो इंटरनेट डिस्कनेक्ट हो गया था तो मैं देख नहीं पाया था सर
And what happens to people who want to see this now?
ओके सर
There is nothing on those slides. Those slides had what you had done earlier at home. Have you found out whether she is within critical period, yes or no?
यस सर
So that is what was in those slides. Then what do you want to see there?
ओके सर
If you want to see slides, that means you have not done it better.
सर देख नहीं पाया था इंटरनेट डिस्कनेक्ट हो गया था तो क्या
No,
होगा
slides
फिर
में
देख
वही
नहीं
होगा ना. It's the same question ना भाई.
यस
Sir, I have one doubt.
Yeah, tell me now. It's 2 minutes gone. Tell me.
Sir, this statement, FSC not applicable as the vessel sitting over blocks, it depends actually the construction of the vessel, right, sir?
Why?
But
Why construction of the vessel? In what form? Better tell me.
sir, the beam, like if the, for example, the naval vessels, अभी recently एक dry dock में sir.
अरे भाई, that capsized during at critical instant or during critical period. They did not capsize when she was outside the critical. This was being refloated. You're talking of Betwa. I'll show you the photo also in 2016. It just toppled sideways. So what I'm saying is yesterday, what did I tell you? If the vessel does not have a broad keel, then there will be side shores which will be placed placed out there. Yes or no?
Yes, sir.
Correct. If the vessel can incline even sitting on a dry dock when there is no water, then everybody's life will be at risk, man. Any wind will topple the ship. Yes or no?
Yes, sir, correct.
Correct. So you can't have that situation in a dry dock that the vessel is sitting on the blocks completely and she still can topple sideways. If she can still topple sideways, then people working in the dock will bloody die because of the vessel's toppling here, right?
Yes, sir. सर जो ब्लॉक्स ये लगाते हैं ये वेसल एकदम मतलब पूरा पंप आउट हो जाता है पानी उसके बाद लगाते हैं या फिर
अरे yesterday what did I say? What happens? What did I say? Did you hear? I said the vessel's docking plan is sent to the yard. Did you listen to that statement yesterday?
Yes, sir.
उसके बाद क्या होगा? अगर yes है तो next.
सर वो वेसल को भेजेंगे एंड देन वी हैव टू
नहीं वेसल को भेजेंगे. Vessel will not prepare the dock for the ship first.
Yes, sir. Vessel will prepare.
Vessel will not prepare. The dock will prepare the yard for the ship as per the docking plan. And docking plan, one of the things in the docking plan is the placement of the blocks, right?
Yes, sir.
So that the underwater fittings like transducer of your echo sounder, like the drain plugs of your tanks, they do not get obstructed by the blocks, right?
Correct, correct.
So every ship and the frame spacing in each ship is different. So the blocks will be placed as per the docking plan of the vessel, right?
Yes, sir.
So the second step, if you guys don't listen to, that is the problem. I said first when it is scheduled to take dry dock a ship, the first step is the plan is sent to the yard. Yard will dry the dock, lay the blocks as per the docking plan, and ready the dock for the ship. Then they will flood the dock. Then the ship, when she arrives, the gates will be open. She'll be taken in. और वो बीच के स्टेप सारे खा गए तुम?
Understood, sir.
नहीं अब ये आज तेरी लाइट जल रही है, कल कहाँ गया था? ये सारा मैं एड्रेस कर चुका हूँ. आई डोंट कट शॉर्ट बेटा, अब सारे बता तो चुका हूँ तुम्हें, तुम दोबारा दोबारा जा रहे हो उसी पे.
सर ये वर्चुअल लॉस ऑफ जीएम वाला पी इंटू के जी डब्ल्यू माइनस पी वाला, ये सर नीचे डायरेक्टली 7605 डब्ल्यू माइनस पी वाला ले लिया था पार्ट.
मैंने W माइनस पी लिया यार. अगर नीचे में W माइनस पी है तो W माइनस पी लेंगे ना बेटा.
मुझे ये कंफ्यूजन हो रहा था सर कि जो इनिशियल अपना डिस्प्लेसमेंट था 8866.3 माइनस.
इनिशियल वर्ड को उड़ा दो, मैंने खुद उड़ाया हुआ है. अगर मैंने गलत लिखा है साला, ये नहीं गलती चलती रहेगी.
ओके सर.
What is W in this W minus P? What is W? Is the ship's
W is the
displacement.
displacement.
And what is P?
Yes.
Upthrust. So if you
P is upthrust.
so then what is W minus P value? You tell me, what is the doubt? Instead of saying वो सीधा ले लिया या टेढ़ा ले लिया, that is a wrong, again a very funny way of learning. It is simply W minus P. What is the W value? What is the P value? And you subtract, what are you going to get? Tell me.
Correct sir, correct.
So don't say it comes from top or left or right. Otherwise, you'll again lose way, beta. You have to just say it's W minus P. W is the ship's displacement. P is the upthrust at that point in time, right?
Correct sir, correct. I was getting confused.
Yeah. So yeah, there should not be anything. This initial word, I had written it. I'll correct it after the class today. This should not be there. Sometimes, I'm also lazy. I don't correct them. But I'll keep correcting as I teach. So I'll keep deleting the things which are wrongly represented by me also in the slide. So there is nothing like initial and final displacement of the ship. Ship has only one displacement because no weights are actually loaded, no weights are actually discharged. Whatever discharging you're talking about is virtual, it's all imaginary to account for the upthrust. Correct? Guys, is question number 4 clear to everybody? Any more doubts in question 3 and 4?
Clear sir.
So I'm closing this and I'll take you to question 2, which we had yesterday skipped.
Sir, in place of initial, what we can write, sir?
Displacement of the ship. W, yeah, W is the displacement of the ship. There is nothing like initial and final. There is no change in actual displacement, na? Or is there a change?
No, there is no change, sir.
So I've been calling it a ship. I've been calling it a ship's displacement so many times. I've called it a. It's a ship's displacement. W is the ship's displacement, right?
Yes, sir. Okay.
Right. Okay. If you call initial also, nothing wrong, but unnecessarily it will confuse you. Then what is the final displacement? Did we discharge? Did we load? No, yeah. Final is also the same. It's a virtual discharge, right? P is virtually discharged. Guys, question number 2 is opposite to what we have been doing in question number 1, 3, and 4. In question 1, 3, and 4, we knew the trim of the ship at the time of entry, and we were wanting to find out the virtual GM. In question number 1, it was found at the critical instant. Question number 2, 3, and 4 at different points. But in question number 2, if you read here, he says MV hinge ship at a displacement of 13383 kg, 7.7 meters, FSM 1000 ton meter. What is the maximum trim by stern with which she may enter a seawater dry dock if the virtual GM at critical instant is not to be less than 0.4? So now in this case, instead of calculating the virtual GM, you are saying, no, you don't want the virtual GM to go less than 0.4 meters. And therefore, and we all know that virtual loss of GM depends on P, and at critical instant, P depends on the trim with the ship enters. So he's asking, what is the maximum trim with which the ship may enter the dry dock? Is the question clear or have any doubts? Let me know. Is the question clear, guys, or any clarity, more clarity required on the question as to what it gives you and what is to be found?
Yes, sir.
Now, in this question, if you see, guys, we don't want the GM at critical instant to go less than 0.4. Now, if you remember, if you recall the table that we were making for finding the virtual GM, we were writing Km minus Kg, GM solid, FSC, GM fluid, virtual loss, and virtual GM. Correct? Why? These were the steps we were following in the table. Am I right?
Yes, sir.
Yeah. So now, how many corrections are involved from GM solid to virtual GM? Look at the table. How many corrections are involved from virtual GM to GM solid to virtual GM?
Corrections.
Yeah, from GM solid to virtual.
FSC and virtual loss.
Yeah, so there are two corrections involved from the GM solid to virtual. So one correction is this one, other correction is this one. Okay. Now, I don't want this virtual GM. I want it to be either greater than or equal to 0.4. That means I'll work for 0.4, right? Anything more than that is welcome. So we don't want this to be less than 0.4. So I will work it for equal to 0.4. Okay. So I want to know how much should be the maximum trim of the ship. And this depends on P. This also depends on P. FSM is of course given. So if this has to be not less than 0.4, then what I should know is how much is the GM solid, so that I know how much can I afford to lose because of two corrections which depend on P. Kg does not depend on P. The two corrections which depend on upthrust are FSC and virtual loss. Am I right, beta? Correct? Two corrections which depend on the this thing upthrust are FSC and virtual loss. Kg does not depend on, so Kg will remain same given 7.7 as far as the ship is concerned. So if I know how much is the GM solid I have in this condition, how much is the GM solid in this condition, then I can know how much can I afford to lose in this range, how much can I afford to lose here. Do you agree with me? Yes or no? Correct, beta?
Yes, sir.
Right. Now, for that, Kg is known to me, 7.7, no issues, but Km is not known. Now, I very emphatically said that Km should be for which condition? Km should be for which condition in our virtual GM calculation, beta?
W minus P.
W minus
W minus P.
W minus P.
Now, so that means to get the Km, I should have P. But then to calculate P, I need Km. So I'm again in a catch-22 situation. To get Km, I need P. To get P, I need Km because I need to work this backwards. Therefore, you have your back against the wall. I am not at all shifting the goalpost. I am again saying Km should be for W minus P. So never ever question this statement. Okay. But when you have your back against the wall, what do? You try to find a way out, correct, Twitter? By a little bit maneuvering this side or that side, correct? Am I right? Yes, sir. When you had your back against the wall, when you're calculating hydrostatic draft of MV Hinship, you needed LCF. LCF comes against hydrostatic draft. You needed LCF for hydrostatic draft for LCF. You were in a again going in circles. So how did you break into that condition? You said, okay, I'll take the LCF for the mean draft because in a ship-shaped thing, it will not make appreciable error. We did that. You remember that, guys? When we don't have a choice. We see what is the best option I can exercise. Am I right? Okay. Correct. And this is not only about ship stability. This happens in physics, science, mathematics, everywhere. Many a times when you do not know the exact value and you need to break through a problem, you solve the problem with the best possible value that you can solve with. For example, when you solve your sites, when you solve your celestial sites, you use the DR position. Is DR your pick? No. Will DR have errors? Yes. Why are you using DR? Because the DR or the EP is the best possible position that you can have to work out the fix. Correct, beta? Am I right? Yes or no? In physics and science, many a times it happens that when we cannot get the exact value to be used, we use the best available value. That means best available value does not mean that it is the correct value. Best available value is whatever best you can logically get. So here, against all my wishes, I will have to use the Km for W instead of W minus P. And this is why I did not want to do this question at number 2, because then there would have been doubts in the minds that sometimes you're using Km for W, sometimes you're using for W minus P. Km is to be ideally, logically, technically, always to be used for W minus P. Here, against all my wishes, because I cannot have any other reference, I'll be forced to use Km for W. Understood, guys? Is that clear? Is that clear, beta?
Sir, please repeat the last statement, sir. Please repeat last.
You repeat whatever I said. I'll complete it.
Sir, I could hear until when km we don't know, so we will use the best available means.
Very good, fantastic. Continue. You are right on track. Bolo.
After this, my connection distorted, sir.
Nothing. So, what is the best possible Km you can get here? Because you don't have clue about P, the only compromise you can make is use the Km for W, right? That's the best possible thing I can do.
Yes, sir.
Correct. And I said this method is not only used here, it's also used in science. Okay. Now, when you use an approximate best possible value and you get a result, in science, you can reuse that result to improve accuracy. So what do? First, you get the result, like in LCF also, in LCF issue also, high draft also. Once we got the high draft, we could have taken the LCF again and calculated a slightly better high draft, but that will not make any difference to the third decimal place. That's why we did not feel the need of putting in any effort there. But in science, when you use an approximate input, because that is the best input you can have, you will get a result. That result is now used to redo the problem and improve the accuracy. And this process is called as iteration in science. You use the process of iteration to improve the results. Okay. Now, when you in science you need high degree of accuracy, you can have first iteration, whatever result. First you use the best possible value, you got the result. You do the first iteration, you get improved result. You do the second iteration, you will get further improved results. You use the third iteration, the results will further improve. So depending on the degree of accuracy that you need, you can continue doing iterations as many times as required in a scientific process based on the degree of accuracy expected. Okay. In R stability also, we will use the process of iteration, but we'll not keep repeating it because we don't have that luxury of time, and also the accuracy required will not be of that order. But we will use one iteration, single step iteration. So have you understood have you had the overview of what I'm talking? Yes or no, before we go to the problem, solving the problem. Is that
Yes,
clear?
sir.
Okay. Go to hydrostatic particulars and get the particulars of the ship. It's a listed it's a listed displacement. So you can get you'll need Km to start with. Okay. You'll also need eventually LCF and MCTC. So those things also you can calculate. Okay. So you see, get all this displacement, draft, MCTC, LCF, and KF. And it's a listed value, so I'll not waste time on it. It has been kept simple because we are not practicing interpolation now. We are focusing on our Drydocking. So this Km for 8.304 Km is not for W minus P, it is for W. Understood, guys?
Yes, sir.
So what will happen? I'll start with this Km. What is my kg? 7.7. This gives me the GM solid of 0.604, right, guys? Yes or no? How much is the minimum GM you need? Minimum GM you need is 0.4 meters. That is as per the question. So minimum virtual GM required is 0.4. So from GM solid to virtual GM, how much can you afford to lose? You can afford to lose a maximum of 0.204 meters. Yes or no, beta? Please tell me if anybody has any doubts.
सर इसमें फ्री सरफेस करेक्शन नहीं लगाएंगे स्टार्टिंग में?
अबे भाई तू इतना समझ में आ गया?
जी सर।
ठीक है, अगर तुम्हें जितना बताया उस पर कोई डाउट है तो बोलो ना बेटा, और जो उसके अलावा डाउट है वो प्रोसेस खत्म होने के बाद रखो.
ओके सर.
Any doubts on maximum permissible loss that I can afford to have from GM solid to virtual GM is 0.204, correct beta? Am I right?
Yes.
Look at this thing that I worked in pen earlier. What were the corrections applicable from GM solid to virtual GM?
FSC and virtual loss.
FSC and virtual loss. What is the formula for FSC? It is FSM divided by displacement.
Minus P.
W minus P.
Yeah, हो गया तुम्हें यार. And what is the formula for virtual loss? P into kg upon W minus. So that means both these losses together should not exceed 0.204. Am I right, guys? Yes or no?
Yes, sir. Yes.
So at critical instant, loss of GM is on two accounts due to FSC. You don't have to write all this, and virtual loss. So, and the permissible loss of 0.204 will be sum total of loss because of FSC and the virtual loss. What is FSC equal to? FSM upon W minus P and P into kg upon W minus P. I know the FSM. I know the displacement of the ship. I know the kg of the ship. What I do not know on the right side is only P. Am I right? Am I right? And on the left side, we know it is 0.204. Does everybody agree now? And now can you solve it for P and be sure that you get a P of 218.9? Please calculate. And then if you have any questions, हाँ भाई FSC का आंसर हो गया तेरा question? FSC is answered?
Yes sir. Yes sir.
If anybody has any calculation problems, you are not able to solve this with LCM, let me know, beta. I'll guide you if there's a problem. Don't sit on it.
सर एक कॉमन नोट लेके कर लिया सर, हो गया सर. 13383
जिसका हो गया वो ठीक है बेटा. If you're getting 218.9, good. If somebody is having problem, then I'm asking. If you're able to get it, then it's fine. whichever way you got, if you are able to get the answer. Any questions up to this, guys? Maximum permissible P at critical instant should be 218.9. Is that okay with everybody? Class, is it okay? Okay, guys?
Yes, sir.
Now,
Yes,
this P, unfortunately, has been calculated by using Km for W, whereas this should have been calculated using Km for W minus P. Correct, beta?
Yes, sir.
So obviously this will have some error. To improve upon accuracy, we will do one stage iteration, single step iteration or single stage iteration. That means what will I do now? I will assume that, see, when I started the question, I did not know whether my P will be 2 in 200, 300 range. Will it be 500, 800 range? Will it be 2000, 4000 range? I did not have any clue. Now, this gives me an idea of P being somewhere 200, 300 tons, So now I'll use this P and repeat the entire process to get the improved value of P once again. So that means now I'll get the Km for W minus P. What I'm doing now is the single step iteration. P obtained above is by taking Km for W and not W minus P. To improve upon the result, single iteration is recommended. Now W is equal to so much. Now we find W minus P. That means this W minus P that we obtained just now, and we get W minus P. And for this W minus P, please interpolate Km and see that you're getting the Km correct, beta. Yes or no? Let me know once you've got the Km, beta. I can continue then.
Yes, sir, they are good.
Okay. Now we'll use this Km because this is an improved Km. I'm not saying this is again accurate Km, no. But this is better than what you used earlier. So now we'll again get GM solid and repeat the full process. So now the permissible loss of GM is 0.221. Can you please calculate the P after the iteration? Can you please calculate P now the same way as we calculated a while back before I show it to you? The maximum, yeah.
During first iteration, which W I have to take? The initial.
How many W's do you have? There is only one W in our question. I've told at least 5 times in the class. There is only one W in the Drydocking process. Guys, have I told it umpteen number of times now? Why this question is coming? Which W? There is only one W to be used. W is to be used only for one value, right? Yes or no, guys?
Hello.
How much is the P?
47.2.
Okay. 247.1 tons.
Yes, sir. 247.1.
Guys, let me know if you have a concern. If more accuracy was required, we will use this PM, find the KM again and repeat. That will be more accurate. You can repeat it once again, and every time the difference between the P that you already have and the new P will keep reducing. That means eventually you will go to a stage where the calculations will not change, stop changing the value of P. You will zero on to the accurate value if you continue the iteration process, but we shall not be doing it because we don't have that much of time, nor is that high degree of accuracy required. So single iteration for us is good enough. Is that clear, beta?
सर वन स्मॉल डाउट सर आपने आई थिंक पहले भी बताया था सर परमिसिबल लॉस ऑफ जीएम एफएससी प्लस वर्चुअल लॉस तुमने क्यों किया सर बट इन द एक्चुअल क्वेश्चन वी वर एक्चुअली सब्ट्रैक्टिंग जीएम सॉलिड में से एफएससी माइनस करके वी वर गेटिंग द जीएम फ्लूइड देन वी वर सब्ट्रैक्टिंग द वर्चुअल व्हाट जीएम वी गॉट मतलब वर्चुअल लॉस दैट देन वी गॉट द वर्चुअल जीएम
So my goodness, GM solid minus FSC minus virtual loss is equal to GM virtual GM. Am I right?
yes sir yes
Yes or no?
yes sir
Correct?
हाँ जी सर
This implies what is the change taking place between these two? GM solid minus virtual GM. The difference between the two is equal to how much? This is coming this side. These two will go on the other side. They'll become plus FSC plus virtual loss. Yes or no?
yes yes हो गया ठीक है सर वो इक्वेशन आ गई समझ
Guys, any more questions about iteration? Why we opted for iteration? Because we started with an whatever best value we could have. We started with Km for W instead of W minus P. Through one step, we are trying to improve. You see, there is already a change in the value of P. What is the P we got earlier? 270 something, right?
218.9
218.9, and now it's 247. If you further do the iterations, it will keep improving, and it will near the accurate value. Now, guys, in question number 1, we knew the trim, and we had to find P. In this question, you have P which is known to you. You have to find the trim. So that at critical instant, if the GM is not to at critical instant, if the P is not to exceed this, you see what will happen. If P becomes more than 247.1, then your FSC and virtual loss corrections will increase, and your residual GM or the virtual GM will go below 0.4, which is the value you have set for yourself. So therefore, you cannot allow this GM to this virtual this P to exceed 247.1. And what does P depend at critical instant? P depends on the initial trim of the ship. Correct? Am I right? At critical instant, the change in trim is equal to P into LCF upon MCTC. Am I right, guys? Yes or no?
Yes, sir.
And what is the change in trim at critical instant? It is equal to the initial trim. So whatever is the maximum trim change permitted, that is the maximum trim with which the ship can enter. Now in this case, this value is given to you. No, this value is not given to you, sorry. This value is to be found. P you have calculated, LCF you know, MCTC you know. You can put this value and you can get the maximum trim. Let me clear all this that I have written here and then show you. These are the values which we had initially picked up against the displacement of the ship. And now, what will be the maximum trim for this P at critical instant of 247.1? Maximum trim will be P into LCF upon MCTC. Don't worry, I'll answer this question. Some of you may say, why this LCF or why this MCTC? And we get this trim of 0.992 meters by stern. So the maximum trim with which the vessel can enter the dry dock is 0.992 meters by stern if she does not want her virtual GM at critical instant to go below 0.4 meters. Please see it, understand it, let me know if there is an issue.
सर एक डाउट था सर छोटा सा इसमें सर जो यही सेम प्रोसीजर अब हम इंशिप में करें ना सर तो उसमें जो एमसीटीसी और एलसीएफ ले रखा है सर वो डब्ल्यू माइनस पी के लिए लेते हैं सर तो वो पूछना
अरे भाई क्वेश्चन नंबर 1 में आपने अभी डोंट यू थिंक दिस इज लाइक एग्जैक्टली लाइक क्वेश्चन नंबर 1 इन क्वेश्चन नंबर 1 you had the trim, you were finding P, am I right?
जी सर
Which particulars did you use in question number 1?
सर इनिशियल जो
correct. Now in this question, so the same formula is being put to use. You tell me what could be the reason for change. It was the same formula which you used in question number 1. Only thing is, in question number 1, this was known, this was to be found. Now this is this is known, this is to be found. Yes or no? Correct. So if I reverse the question number 1 with W minus P particulars, will the answer come same? No. Correct, beta?
Correct.
Okay. So basically, I'll tell you one thing. So basically, there is no need to change. Now I'll tell you how to resolve this issue in your mind once for all. Which particulars to use? Now here, if you use particulars for W minus P, they will also yield error. If you use particulars for W, they will also yield errors. Why? Because you are picking up particulars against a certain draft and then you are assuming them to be constant throughout the range of the question. Correct, beta? Yes or no?
Yes, sir.
So the moment you assume the particulars remaining constant, that is going to result into some error. Either whether you take it for W or you take it for W minus P. None of them can be claimed to be absolutely correct because you are converting this question into a fixed particular question despite the hydrostatic tables being available. Correct, beta?
Okay, sir. Okay.
Okay. So now, which particular should you use? Now pay attention and this will remove all your doubts. If there is a reason, now this statement I'll ask you to repeat when we use any particular for W minus P, and then you'll say why you are using for W minus P. Pay attention to what I'm saying. If you know that a certain particular is accurate for W minus P if used, then you'll use that. If you know certain particular if used for W is accurate, you will use that. But when you know that particular is neither for W nor for W minus P, then it is better that you use with the particulars with which you start. Why? Because they are always available to you. W minus P particulars will come only after P is calculated. These particulars are available upfront, correct?
Okay.
I'll give you an example. Like, we know that Km, I gave you the reason yesterday, when you are calculating the virtual GM, Km depends on the draft of the ship. And once you have calculated P, you are in a position to use the better Km. So you know definitely that the Km should be used for W minus P. So there we don't compromise, right, beta?
Yes, sir.
Okay. So wherever you think that a certain particular in a question is absolutely accurate for W minus P, there that particular will be used for W minus P. Otherwise, we'll continue with the particulars with which we start off. Is that clear?
Clear, sir. Clear, sir.
And one example of my state to support my statement, I have given you for Km. That Km we use for W minus P. Right,
Yes,
beta?
sir. And free service rate.
Okay.
Yes.
Guys, please let me know if you have any doubts here. Anybody wants to relook at the question, not for taking screen. The guys, one thing you have to, leave this habit of jotting down, taking screenshot. You take them, it doesn't matter to me. But that, what happens is that makes you go in a easy mode. I'll learn it later. And that later thing never happens. If you can't learn it in the class, forget about learning it later. Yeah. So please, you can take as many screenshots you want. I'm not saying don't take the screenshots, but don't actually waste your energy and time on collecting data. You don't have time to keep going through what you're collecting from different sources. It is time when you have to learn and execute. Guys, is the question number 2 clear? We have done single iteration here because we were forced to start with Km for W instead of W minus P. If everybody is happy, I'll go to the next question. If you have any doubts, I'll be happy to wait here for another 30 seconds or so to hear from you if there's any doubt. Can somebody confirm the time? What is the time, beta?
140.
Sorry?
10:40.
10:40. Okay, 10:40. 10:49, 30. Okay, we can take one more question and then I'll give you the break. Yeah. Then might as well push the break a little bit. It's too early for them to go into break. Is it clear, beta? Question number 2 clear?
Yes, sir.
Okay. If you have any doubts coming to your mind, let me know. So we are done with question number 1, 2, 3, and 4. Now, guys, what is the difference in this question? Tell me.
First, we have to find drafted
Sir, fresh water.
No, what is the difference? Identify the difference in the question. What is the difference?
Fresh water.
Density, sir.
density.
Only the density change, correct, beta? So that means the Drydocking working will be same. Only things, the particulars have to be used correctly. Am I right?
Yes, sir.
And how do we get the particulars in correct density? We discussed it in the first class. Those 4 scenarios. Draft given in seawater, displacement given in seawater, draft given in non-seawater conditions, and displacement given in non-seawater conditions. You remember that, guys? Yes or no? Correct? Am I right?
Yes, sir.
Okay. So dry docking process will remain same as you learned in question number 1 or later on. Only thing is you have to just make sure that correct particulars are used. So can you please get the height draft of this ship? This is in fresh water. Please remember, can you get the height draft? Get the height draft, please.
4.580.
4.580. Okay, I'll show you in a while. Can somebody validate? Please write. Is he right, guys? 4.580?
Sorry, 4.191, sir. Sorry, sir. 4.191.
Okay. 4.191, is it?
Yes, sir.
Okay, 4.191 is the corrected value from him now.
4.
Can you validate?
4.191, sir.
Okay, very
4.19.
good. Okay, others? Guys, see, I told you something on day 1. Speed up with the interpolation. You see, if calculation of height draft is creating a time difference of 20-30 seconds between the first person in the class and maybe the person who's taking time. So just imagine this 30 seconds taking an interpolation and draft here. If you keep adding because of the interpolation required and stability, this will total to good 10 to 15 minutes difference. So you can't take your interpolation speed lightly. Accuracy, of course, nobody can take lightly, but at the same time, please value the speed also. Not for my class, for your exams. And class is the best place to practice and improve your speed also. Okay, you have got the draft. Let me show the draft then. Has everybody got the height draft, guys?
Yes, sir.
Okay, guys, tell me now. He wants the virtual GM at critical instant. Which particulars, now we have done 4-5 questions. Which particulars should we be interpolating? Name the particulars that we should be interpolating for 4.191.
The displacement, MCTP, LCF.
The displacement, MCTC and LCF. But my vessel is displacing 4.191 in which water beta?
Salt
Water, fresh water.
Seawater.
She's displacing this much in fresh water, right?
Yes, sir.
So this is which case? It is the third case where the draft is known in fresh water, right? In that case, what will you do? What will you just repeat the step? What will you do first? You will enter
displacement first and then convert, sir.
Equivalent displacement.
Equivalent displacement.
अरे ड्राफ्ट दिया है, डिस्प्लेसमेंट कहाँ से आ गई इक्विवेलेंट? When is the equivalent displacement case comes? And those who are speaking, they are at least highlighting their weaknesses and probably will be able to correct. You will not be the only one in the class, guys. I can tell you. There will be a reasonable number who take a back seat and don't speak up. Guys, here you have a draft given in non-seawater conditions, correct? Yes or no? A draft of 4.191 in fresh water, correct? How do we get the particulars? Tell me now.
Sir, weight in seawater by density in
Change in
seawater
seawater.
into density in
Tell me
groundwater.
tell me the first step you'll take.
The change is draft to seawater, sir.
How?
Sir, one.
Gaurav, were you in the first class, beta?
Yes, sir, I was.
After that, did you bother to go through first 5 questions of MBA inship?
Yes, sir, I did.
So when the draft is given, you change the draft to seawater. How do you change the draft? I have never learned it here. I would
You
like
take
to learn.
displacement लेंगे, then
Sir, draft system will calculate the displacement for seawater, then we'll do displacement in seawater by density in seawater into density in groundwater.
One statement I expected was, we'll get the seawater particulars for 4.191. Is that correct?
correct, sir.
Yes,
Yes,
sir.
sir, correct.
Why can't you talk, when you talk to yourself also, why can't you talk to yourself crisply and technically correct, in a technically correct language? That means I have to get the seawater particulars for 4.191, and then then we need to get the particulars for 4.191 in fresh water. Am I right? Am I right, guys?
Right, sir.
Yes, sir.
तो यार इतना करने के बाद अगर ऐसे करोगे, you will learn dry docking, but you will mess it up in these issues, and then you will come and blame yourself and hit your head with the wall. So first, with 4.191, that's why the density column is important. When you enter the tables, you'll get the particulars for seawater. Can you please interpolate and confirm?
Confirm, sir.
Okay. Then get in the next row, just below it, change the density to fresh water, keep the draft 4.191, and get the particulars. I thought I'll not have to waste time on this issue today.
So displacement 7822.9.
Okay. See, guys, everything we are using, I have covered it up. And I have not left it to chance that somebody may know, somebody may not know. Now, if you do not know, then it's purely your lack of interest or lack of effort. I could have understood if I had not explained to you. I could have understood if this was the first time it came, some of you were lost. I could have taken that. But having invested one full session in the beginning, and today, if you are going in circles, then there is a problem. So which particulars will you use to solve now? Now you have everything to get the P at critical instant. Can you get the P at critical instant, guys, now?
171.5.
Okay. So you will use the freshwater particulars. You will use, this is the ship's displacement. This is the ship's MCTC to be used, and this is the LCF to be used. So these are the particulars you will use in solving the question. Am I right?
Yes, sir.
So here you can see it's 171.5, right? Is everybody getting 171.5 tons P? Yes or no?
I'm still calculating. Yes, sir.
Calculate.
170.
Let me know. Let me know once you're done. Let me know once you're done.
Yes, sir. 175.
Okay. Anybody still solving? Please let me know. I'll wait.
Yes, sir. 171.5.
Okay, fine. Now, guys, what do we need? Question says virtual GM at critical instant. What do we need now for that? What do we need? Say again, beta. Sorry, I didn't hear you.
W minus P.
AM for what? W minus P.
W minus P.
Okay, what is the ship's displacement? Tell me from the screen.
7822.9.
7822.9. And what is the P? 171.5, right? You need displacement km for this. Am I right? Yes or no?
Yes.
Correct?
Yes,
But with this W minus P, where is the ship going to be? In which density?
For freshwater, sir.
Freshwater.
This will be W minus P in freshwater, correct?
Correct, sir.
So you have to get km per freshwater, right?
Yes, sir.
Yes, sir.
So now which situation? 1, 2, 3, 4. Which category it falls into? You know the displacement in non-seawater conditions, right?
4.
Yes. 4. So now you'll have to get the equivalent seawater displacement. Correct.
Then we'll go and find the game.
7842.7.
You can see it here. Up to this you did. Then W minus P in freshwater is so much. Now this has nothing to do with dry docking. What we are now doing is nothing to do with dry docking. You know the dry docking process. The problem if you're facing, it's facing because of the fundamentals. Better. So don't think dry docking is complicated. Excuse me. And this will be the equivalent seawater displacement. Once you get equivalent seawater displacement, what do you do?
KM.
You will enter the tables with equivalent seawater displacement and get the particulars and then convert them to excuse me, required density of fresh water. Correct, but you remember that part? Yes or no?
Yes, sir.
So for part A, for part A, we need KM. Also get the draft for part B because part B says, oh sorry, when the level falls by 1 meter. So get the draft at critical instant also. Now calculate this then.
Okay.
First you will get for seawater, then you will get it for fresh water.
So draft is 4.110.
Okay. Get the KM also.
9.725.
but these values are for seawater. We need it for fresh water. Excuse me here. I don't know why it has happened. Is the presentation? I'm just muting my. Give me a second, guys. Okay, guys. I hope it's clear so far. Sorry, I took break. Yes, sir. Okay. Now, using this KM, which KM? They may be same values, but always learn the right practice. Using which KM? Using this KM for fresh water. Can you find out the virtual GM? That is answer for first part, beta. How much is it?
1.3.
1.3?
1.312.
1.2 meters. Okay. So if two people are saying, must be correct. So guys, if you have a problem with the conversion of particulars, please pay attention to the basics. Don't allow your hard work, your effort in dry docking grounding go down the drain because somebody has changed the density in the question. So that's why I'm bringing in these variety of questions so that whatever possibly they can bother you with is all automatically covered here. There's no point in doing 20 questions of the same type. You do 20, you do 50, unless you learn and do them, it's not going to be of help. You can't be mugging up every question. So also remember, this is the draft in fresh water at critical instant. So at critical instant, the GM is 1.312 meters, right guys? Correct?
Yes.
Now this, any questions up to part A, beta? Part A answer is this one. Okay. Then the second part is find the virtual GM when level falls 1 meter after the critical instant. That's why we got the draft at critical instant. Now see, draft at critical instant was 4.110 meters. Am I right, beta? Have I taken the correct value? Yes, or no?
Yes, sir. Yes, sir.
For
Yes,
part
sir.
B, he wants further fall of how much? 1 meter. So that means for part B, depth of the water is equal to, or depth of the water or the draft of the ship is 3.110, because now the vessel will remain even keel. She's sitting on the blocks completely. Am I right? Am I right, guys? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Correct? Now for part B, how do you think we will be able to get the P, guys? Tell me, how do we get P? There are only two ways of getting it. Which method will apply now?
W minus by and C.
W minus B. Does everybody agree?
Yes, sir.
So that means for 3.110, we'll get the displacement in fresh water. That will be the buoyancy support, and we subtract it from the displacement of the ship, and that will be the P for part B. Second, what will be Km? Km, tell me this 3.110 meter draft is for W or W minus P, or is it for something else?
For W minus P.
So we'll get the Km against 3.110 in fresh water. So remember, for 3.110 meter in fresh water, you have to get the displacement and you have to get the Km. Using the displacement, we'll be able to get the P, and using the Km, we'll be able to get the virtual GM, because that will be the Km for W minus P. Guys, I explain you before I show the slides so that when you go to the slides, it makes better sense. After the level falls by 1 meter after the critical instant, high draft at critical instant 4.110, further fall 1 meter. So the depth of the water for part B is 3.110, which is also equal to high draft for part B. Okay. Now, density, when you enter with 3.110, the hydrostatic particulars, you will get in which density, beta?
Seawater.
Seawater. Right? So for 3.110, this is the displacement in seawater. This is the Km. But my vessel at 3.110 is not in seawater. My vessel is in fresh water. So in fresh water at 3.110, this will be the displacement, which is W minus P. Am will remain same. So these are the particulars to be used hereafter. Am I right, beta? Correct? Clear, class?
Yes, sir.
No, I
Yes,
think
sir.
there is something missing. Suddenly people seem to have lost out. Is it okay?
Okay, sir.
So now how do we get P? The displacement of the ship minus W minus P, or W at 3.110 in fresh water. So the upthrust will be, again, this initial word is a misfit here, in fresh water. It will be displacement of the ship minus displacement at 3.110 in fresh water. We can put these values and we get a P of 2,253.6 tons. Please check
सर ये
and see.
केएम थोड़ा ऑफ आ रहा है
सबका ऑफ आ रहा है बेटा.
11.432.
432 it is. Okay, let's make it 4. Everybody is getting 432?
Yes, sir. 432.
Okay, make it 432 then. Okay, no problem. Take it.
PS 2253.7.
Sorry?
2253.7.
Okay, 53.6, 53.6 or 0.7 is okay, no problem. Don't worry. That's okay. So we have got P for part B now. This is part B we are solving, but a part A was already closed out. Now, once we have P and we have the Km, then we'll get the virtual GM. It will be Km minus Kg, but is the vessel within the critical period or outside the critical period for part B, guys?
Outside.
Outside. What will happen to FSC?
Not applicable. Not applicable.
Not applicable.
applicable.
Please do that and find the value. Find the value of virtual GM.
3.278.
Since I have started with 434, so maybe there will be a last in the, it will be yours will be then 0.054. Am I right?
Yes, sir. 0.05.
Yes, sir.
Because I have started with 4, so if I make it 2, this will reduce by 2 here. So guys, question 5, if it is bothering you, then why is it bothering you? It is bothering you because you are struggling with the particulars in different densities. Through this question, what did I try? What was my intent? My intent was to make you realize that once we had the draft in different densities, so we had to use method for third condition. When it came to Km, we had to use the displacement in fresh water. So we used the fourth condition. So third and fourth conditions have been revisited here, and that was the intent. Now, if you are struggling in that, you are the best person to figure it out, and then you are the best person to put in effort and put that issue to rest, because that has nothing to do with dry docking grounding. That has all got to do with the basic issue. If this was a seawater question, I'm sure none of you would have got stuck. Am I right, guys? If in question number 5, if I replace fresh water with seawater, I think everybody would have run away with the question. Am I right? Correct, guys? Okay. So now we have finished 5 questions. You can review question number 5 during the break. Can somebody confirm the time better?
11.5.
11:05. So take up. Okay.
6 over,
Okay. So what time? 11:20 you want to start? 11:25. What time you want to start? Tell me. 11. Okay. I
11:25.
Okay, 11:25, but with the condition that you will review question number 5 based on your individual requirements. And if you have any doubts in question number 5, let me know immediately after the break. Is that clear, beta? Okay. So 11:25, we resume the class, and I'll first ask you if there is any doubt in question number 5, address that, and then move on. Okay. Let's take a break then.
Okay.
Hello? What's the message? Okay, guys, sorry. Any problems, doubts, guys, up to question number 5? Class, any doubts?
No, sir, no doubt.
No, sir. No, sir. Okay. So, yeah, so now you have this.
सर आपकी आवाज नहीं आ रही है
सर आवाज नहीं आ रही आपकी सर आवाज नहीं आ रही आपकी
सर आपकी आवाज नहीं आ रही सर
Guys, raise your hand so sir will understand.
सर आवाज नहीं आ रही सर आपकी
सर आवाज नहीं आ रही है सर
हेलो
हाँ
सर
सर, अब आ
आवाज
गई।
नहीं आ रही आपकी Hello.
हेलो सर
सर अभी आई थिंक लॉग आउट किया, दोबारा लॉग इन करेंगे.
सर ने क्या छुट्टी दे दी
ഇയാള് എന്തൊക്കെയാ പറയുന്നത്?
Am I audible now, guys? There was some, I think, some glitch which was preventing the sound reaching you, right?
Yes, sir. Now audible. Yes, sir. Now audible.
Now audible. Okay, fine. I had to go out of the meeting. Okay, fine. So what I was saying when we got disconnected was that you are all okay up to question number 5, and we were to continue after that. Now, the first thing is we have to understand a term called declivity of the dock. Okay. Now, what I was saying is in all the questions that we have done until now, we had assumed that the dock bottom, the bed of the dock was horizontal. And all the blocks were of the same height, obviously. And because of these two factors, what factors? Seabed being horizontal and blocks of the same height, as a result of it, at critical instant, the trim of the vessel became 0. Am I right, guys? Yes or no? Correct?
Yes, sir. Yes, sir.
Correct. Yes. Now, what happens is when you pump out the dock, like the ship's tanks, you have a bilge well, and the pump suction is put here like this. And here the gates are closed, and you pump out the dock. So what happens as the dock gets empty? The water keeps flowing to the bilge well from where it is sucked. Now, if the seabed, if the bed of the dry dock is made horizontal, then what will happen? The last part remains of the water will not flow freely to the well, and there'll be a lot of puddles of water left, and it will take time to drain to the bilge well. Like if you want to empty a tank when the ship is upright and even keel, you have a problem. So what do? You list and trim the vessel appropriately so that the liquid in the tank can flow to the bilge well. Correct, Beta? Yes or no? Correct?
Yes, sir.
Am I right? Another example is the roof of your house. You don't keep the roof of your house horizontal. Why? Because if you keep it horizontal, then to the rain pipes, the water will take time to reach the rain pipes and you may not get a dry roof. Therefore, what do? You have an appropriate slope of the roof so that the rainwater can easily drain to run to the drain pipes and gets drained out. So to facilitate that the dock gets empty easily, most of the times, instead of having a horizontal seabed, the dock bottom has a slope. Okay. And if the dock bottom has a slope, and here is the bilge well, and here is the dock getting over, then I'm sure you'll understand that the water can easily flow to the bilge well. If the bottom has the slope of the bottom of the or bed of the dry dock is what is called as declivity. So what is declivity of the dock? Declivity of the dock is the slope of its bed or its bottom. Understood? Or its floor. It's the slope of the floor of the dock that is called as declivity. What is the purpose of providing declivity? To facilitate drainage of last remains of water to the well. Right, beta? Am I right? Clear? Clear, guys?
Yes.
Now, how is this declivity expressed? So you have understood. So what have you understood? What is declivity? Second, its purpose, why declivity is provided. Third, how is it expressed? Now, if this is the bottom of the dock, this is the slopey one, and let me draw the horizontal line below this. So what happens? Here both are meeting. Now the slope is expressed as, you see, if you see at this level, this is the difference in the heights. If you see at this level, this is the difference in heights. If you see at this level, this is the difference in heights. That means starting from the point of starting, that is x. So the declivity is expressed like in like so many centimeters per 100 meters. That means if from here to here, it is 100 meters of length, and this difference in his height is x centimeters, then the declivity is x centimeters per 100 meters. So declivity is expressed as x centimeters per 100 meters of the length. Have you understood how declivity is expressed, or any questions, guys? Clear? Is that clear, beta?
Yes, sir.
Now, on this slopy bed, if I put the blocks of the same height, then what will happen? The top of the blocks will not be horizontal. That will also have a slope. Am I right? Correct? Yes or no? So when the ship sits on these blocks, she will not be even keel. She will have a trim towards the stern, because ship always enters with bow first. So when the ship sits on a blocks in a dock which has declivity, she will not have zero trim at critical instant. She will have some trim at critical instant. Do you agree with me? Yes or no? Correct?
Yes, sir. Agree.
So now see, if there is a 50-meter long ship which comes and sits here, from here to here, let's say this is 50 meters. So if a 50-meter long ship comes and sits on this in this dock, she will come and sit like this. Anywhere, even inside, deep inside, does not have to be at the edge, it can be anywhere. Now, what will be the difference in the draft forward and aft end? What will be the trim? Trim will be equal to this part. And this will be equal to how much? This is if x is the declivity per 100 meters, and if the length of the ship is 50 meters, then this will be x by 2 centimeters. Correct? The vessel will have a x by 2 centimeters trim when she sits completely. Am I right, beta? Yes or no? Correct?
Yes, sir.
Now, if the same ship was 100 meters long in the same dock, now the trim will be equal to x centimeters. Correct? Am I right?
Yes, sir.
If she was 150 meters long, how much will be the trim? 1.5x, right? Correct, beta? Am I clear, class?
sir. Yes, sir.
So, firstly, what is declivity? Have you all understood? Declivity is the slope of the bed or the floor of the dry dock. What is its purpose? Purpose is to facilitate drainage of last remains of water. How is it expressed? It is expressed as the height of the slope floor per 100 meter of length. What is its effect? Its effect is that the ship is not even keel when she sits on the blocks. She will have a trim which will depend on the declivity and the length. So the trim at critical instant or after that will depend on how much is the declivity and how much is the length of the vessel. Why? Because declivity is given every 100 meters. So depending on the length of the vessel will have some trim when she sits overall. Is the declivity component clear to everybody? Anybody has any questions? Please let me know. This comes in theory also at times besides the numericals, right? So if it comes in theory, you should not be just writing rubbish. You should be technically expressing it the right way. So if anybody has any problems, let me know.
सर ये x by x सेंटीमीटर अपॉन 100 ये समझ नहीं आया सर, ये कैसे बना सर?
क्या बना? ये हॉरिजॉन्टल है. अगर सी ड्राई डॉक का बेड हॉरिजॉन्टल होता तो ऐसे होता, बट द ड्राई डॉक bottom is inclined like this. How much is the difference here between the slope and the horizontal?
X sir.
Yeah, at the dot. What is the difference here?
Zero,
what is
sir.
the height difference between the slope and the horizontal?
Zero sir.
Zero. If I go 100 meters from here, then this is the difference in the slope, right? Okay.
Yes, sir.
Let us say it is x centimeters. X is any value. So that means now what will be the declivity of this dock? It will be x centimeters of height every 100 meters of length, correct? Is that
Correct.
understood now?
Yes sir, correct.
Okay. Any more questions on declivity, guys? Let me know. I'll be clearing the screen then. And the effect is that the vessel will not have zero trim at critical instant then. The trim of the vessel will depend upon the declivity taken into consideration with the length of the vessel. Am I right, guys? Yes or no? Correct, sir. So I'm clearing the screen unless anybody has a doubt. Please let me know. The declivity part I've explained to you now. Okay, let's go to the next term then. So guys, as I promised, I'll be covering the theory related to the topic as we run through it. Second, this question comes in theory. Why do vessels prefer to dry dock with slight trim by stern? Okay. Now you will answer this question in two parts. One, you will answer why trimmed by stern. And second, you will answer why slight and not excessive. So you will answer it in two parts. Why you want to dry dock the ship trimmed by stern is, I'm answering that one first. If she dry docks with trimmed by stern, then the first point of contact is the stern frame. Is the stern frame. Okay. And this stern frame is specially strengthened. Stern frame is specially strengthened during ship construction to withstand dry docking stresses. So have you understood why would you prefer to dry dock the ships trimmed by stern? Am I clear about it? Clear, beta? Is the first part clear, guys?
Yes.
Why would you prefer to dry dock the ship trimmed by stern? Because if she is trimmed by stern, the stern frame of the vessel makes the first contact, and this particular member of the ship is specially strengthened during ship construction to withstand the dry docking stresses. Right? Second, why this trim should be slight and not excessive? This trim should be slight and not excessive because of the two formulae which you already know. At critical instant, P is equal to trim caused into AF upon MC upon length upon MCTC, right? MCTC. Okay. Now, this upthrust P is, you can see in this formula, is directly proportional to trim caused, and trim caused is equal to initial trim of the vessel F at critical instant. So is equal to initial trim. Therefore, if the initial trim is more, upthrust at critical instant will be more. If the initial trim is less, upthrust at critical instant will be less. Do you agree with me? Yes or no, beta? Correct? Okay. Now, why do you want to have less upthrust? Because the formula for virtual loss, you know, is P into kg upon W minus P. Okay. So when you talk of virtual loss, this virtual loss is also directly proportional to P. So if P is more, then virtual loss will also be more, and the vessel will have a higher risk of getting into unstable equilibrium, or stability will be compromised more. So you do not want the P to be excessive. And to control the P and to prevent the P from being excessive, you have to control the initial trim. Therefore, vessels prefer to dry dock with slight trim by stern and not excessive trim. Is that clear, beta? Is it clear to everybody, guys? You know it. I've only told you how to answer it. Correct?
Yes, sir.
Okay, so if they come in theory, don't write stupid things. Be very technical, be very specific, as mathematical with formulae as possible. Don't start writing 100 pages without any content. So is this question also clear, guys? I'm clearing the screen then. The last formula, I'm not very interested, but if somebody is wanting to use it, this is the other formula. As I said, this is based on the fact that P is not virtual discharge. P is supplementary or additional, or is additional buoyancy, which supports W minus P. So the weight of the vessel remains W only, because there is no virtual discharge. So I don't think many of you would like to use this formula. It is just mentioned here for the sake of closing out the issue. So these two theory questions. So there are three theory questions I have covered for dry docking. Critical period, critical instant. Why is it called critical instant? Why is it called critical period? What are they? Then so 1, 2, and 3. Three theory questions on dry docking I have addressed. Correct, Peter? Yes or no?
Yes, sir.
Okay. Now we will take a question in which we'll have the declivity and we'll have fixed particulars. So guys, in MMD exams, you'll have two types of questions. One based on MV hinship or fixed particulars. We have done 5 questions involving MV hinship. You should actually practice them more. Why? Because fixed particular is always simpler. You don't have to take out the particulars, they are available to you in the question. Okay. So, but fixed particular questions also do come in the exam, but you will not have any problem. So I'll now take a question where we'll have declivity and we'll also have the fixed particulars addressed in the question. Here is the question, guys. A ship of length 150 meters, displacement 5,200 tons, center of flotation 2 meters aft. So if center of flotation is 2 meters aft, then LCF will be 73 meters, 75 minus 2. MCTC 140 ton meter, KM 6.5, kg 6 meters. So you don't have to worry about KM for W and W minus P. There is only one KM. Then you will have TPC, FSM given, draft forward and after given is to be tried out. Calculate the residual GM and drafts forward and after. So GM plus draft at critical instant. If the dock has a declivity of 30 centimeters per 100 meters. Now, guys, look at the declivity given and look at the length of the ship. What do you think will be the trim of the ship when she sits on the blocks completely? What do you think will be the trim?
45 centimeter.
45 centimeters.
Is that a complete answer? Please give a complete answer.
By stern.
By stern. 45 centimeters by stern, correct? So when the trim of the ship reduces to 0.45 meters by stern, the vessel will reach critical instant, correct? Unlike the previous cases where it was reaching critical instant was when the trim was becoming zero. Am I right, guys? Yes or no?
Yes.
Clear? So tell me, in question number 1 to 4, if I talk in terms of declivity, what was the declivity in questions 1 to 5?
Zero.
Zero. So if you want to bring in declivity there, the ship had zero declivity. Now the declivity is 30 centimeters per 100 meters. So, guys, what is the initial trim of the ship?
1.06.
Give the complete answer. Don't say 1.06.
1.06 by stern.
Yeah, so you have to be careful. What is the trim at critical instant? You've already told me it's 0.45 meters by stern. So how much is the change in trim required for the vessel to reach critical instant? It is 0.61 meters by head, right? Correct? So TC will be 61 centimeters. So now if you have TC 61 centimeters, can you find P at critical instant, guys? All the values are on display.
117, sir.
117.0. Is he right, guys? Or anybody is having difficulty in getting it? Tell me. Anybody having, see how easy it becomes with fixed particulars? So don't ever think that you're not done with fixed particulars. They are much, much simpler than MV in ship.
Yes, sir. 116.986.
So 117.0 round off to one decimal place, right? Everybody
Yes,
is
sir.
good with. Now, once you have P at critical instant, can you please find out the virtual GM? You all know how to calculate it. Get the answer. Get the answer, you know the process for getting the virtual GM.
So 0.138 meters.
0.138 meters. Okay, this is one answer from the class, guys. Is he right? Is he right, guys? Virtual GM is 0.138 meters. Is that right? Or something else?
Yes, sir. 0.138.
Okay. Guys, is the first part of the question clear? Residual GM. So it's so simple compared to what you have been doing all this while. We still have another part of the question to be done. That is find the drafts forward and aft.
So this is virtual GM, right? We need to calculate residual GM.
That is the same as virtual GM, beta. GM at residual GM at critical instant is same as virtual GM at critical instant. Residual means how much is the GM left with the vessel, right?
Yes, sir.
It's the same thing. Okay.
Okay, sir.
So you got 0.138?
Yes, sir.
Okay. Guys, everybody is good with the first part of the question, correct? And that itself should give you the confidence that you know certain processes of dry docking now. I'll show you the solution later. Let me close it out here on this page itself. The second part is to find the draft. There are two ways to find. You have to know, do it one way only, but you must have clarity of both. So don't say, sir, I want to do this. Okay, do that, no problem. But you can't say, should I care to hear about part two? Yes. Now, one way you could be doing is, since you know P at critical instant, because he wants a draft forward and aft at critical instant now is 117 tons. Okay. Now, guys, your draft forward and aft will not be same. The vessel shall have a trim. So your drafts will not be same, unlike the earlier cases where there was no trim. Okay. So one way of doing it is we get the initial height draft. Look at the, so this is 73. Guys, can you please calculate the initial height draft? You know values are on display. I will write the value only when you give, and I will explain if anybody has a specific doubt. Get the initial height draft, please. You know how to get the height draft, beta. 4.89.
4.869. 4.86.
869. Is it right, guys?
4.8947.
894. 89. Okay, 4.894 seems to be a popular response.
4.894.
4.894. Okay, good. Somebody who said 869, please see where have you messed it up better.
4.894.
Okay, fine, good. Now, guys, height draft changes for on what grounds? What are the triggers to change height draft?
Displacement density.
Density and displacement, sir.
Density is not in question, so it has to be displacement. So at critical instant, how much is the virtual discharge? How many tons is the virtual discharge at critical instant of thrust?
117.
117. Will that cause mean rise or sinkage?
Mean rise.
So can you calculate the mean rise and give me in meters? It will be 117 the upthrust divided by TPC 20, so many centimeters, and I divide by 100 to convert into meters. How many meters is the mean rise, guys? You know all this now.
0.058.
Point 0.058, is it?
Yes, sir. Decimal 0585.
0.5.
0.0585.
0.58 or 9? Is it? Okay, let me make it.
No, sir. 0585.
0.85 will become 9 now, beta.
0.059.
Yes, sir. Yes, sir.
0.059. Okay, fine. Guys, if I apply the mean rise to the initial hydrostatic draft, what will I get? Tell me. What will I get?
Sir,
Tell me what do I...
Draft at critical instant.
It is high draft, not draft. It is high draft at critical instant, correct? That will be 4 and 5. Sorry, my mistake. Then 8, 3, 8. Is it 4.835 meters? Is the high draft at critical instant?
Correct, sir.
Yes or no, guys?
Yes, sir. Yes, sir.
Now tell me, if I am using the high draft at critical instant, name the trim that I should use. TA, TF of which trim should I use? Name the trim. Don't give the value. Name the trim. Final trim. That means trim at critical instant, right? What is the trim at critical instant, guys?
0.45 meter by stern.
Very good. It's very important to remember the name. By stern. Using the LCF and the length, can you give me TA and TF beta? Can you give me TA, TF using the LCF and the length of the vessel?
TA is 0.219 meters.
219.219. The other one is then point
231.
231. 231. Right, guys? So now, since she is trimmed by stern, TA will be added, TF will be subtracted. So you have the forward draft, you have the aft draft, you have the height draft, 4.835, 4.835. Apply TA, TF to it. TA under. One second. Okay. TA under aft draft 0.219. TF under the forward draft 231. Since the trim at critical instant is by stern, TA is added. See, I'm talking to myself. TF is subtracted, and you will get the draft forward and aft.
Forwards are 4.604. Aft is 5.05.
05?
054.
4, okay. Is it okay, beta? Clear? Is it clear, beta?
Yes, sir.
This is one way of getting the drafts forward and aft. So I hope.
Sir, for calculating TA, we have used TC as 0.61, right, sir?
You were not in the class, is it?
Yes, sir, I was there, sir.
So after the height draft, what question did I have put in the class?
Sir, you wanted to.
What question did I put in the class after we got the height draft at critical instant 4.835? What was the question posed to the class?
Sir, what is the trim at critical instance?
So if you have a height draft at critical instant, you'll apply TA, TF of what? We have already discussed it at least twice in the class, beta. If you know the height draft, then what will it will be TA, TF of what?
Sir, it will be for the high draft, sir.
So if you have the height draft, the TA, TF component will be of which trim? That is the question.
It will be the trim at the trim at critical instance.
At that particular time for which the height draft is used, yes or no?
Yes, sir. Yes, sir. Correct.
So what is the trim at critical instant?
0.45.
By stern, right?
By stern. 0.5. Yes, sir.
Correct?
Yes, sir. Correct.
Correct, class? Okay, now I'll use the other one which you have used in trim type A. And I'm doing it here intentionally so that this concept is sunk in well, yeah, once for all. You cannot keep going back and forth on that. Now, we have the forward draft initial, we have the aft draft initial. Forward draft is, where is it? 4.350. Aft draft is 5.410. Guys, what is the initial trim? 1.06 meters by stern. We just had it on the screen before I cleared it. Correct? Initial thing when we were calculating. Correct? Correct?
Yes, sir.
Am I right? What is the
Yes,
trim
yes.
at critical instant with name?
0.45 by stern.
By stern. What is the change in trim at critical instant?
0.61 by head.
Meters by head. Is that clear to everybody? These are the three trims. We have to decide TAT of what. Now, when you would virtually discharge 117, that will cause mean rise of how much? 0.058. 058. 0.058. Why? Because now we have not applied the rise or sinkage to height draft, so it has to be applied at both ends. Now, guys, to this, first tell me, it will be TA, TF of which trim? I have written three trims there. It will be TA, TF of which trim?
A trim cost.
He is saying trim cost. Does everybody agree with him?
Yes, sir.
Does everybody agree this? So here also we wrote TATF. Here also I'm writing TATF. But I'll go back. What has happened to it? Why is it? Okay, it's coming. I've written TATF here. I've written TATF on the right side also, but in the red one, it was TATF of the trim at critical instant. In the green one, we are saying it's TATF of trim change. So can you please find TATF of 0.61 beta? What is TA equal to?
0.297.
297 TF and TA, and TF will be how much then?
0.313.
Does everybody agree with this TATF split of TC beta? Yes or no?
Yes, sir.
Now this gets applied to the after draft, you will have 0.297. To the forward draft, you will have 313. And mind you, the trim change is by head. If the trim change is by head, the TF component will be added and TA component will be subtracted, and you will get the same draft 4.604 and 5.054. Sometimes in the third decimal place, there may be one shift up or down because of rounding off. Otherwise, fundamentally, they are both same answers. Have you understood both methods? I have done it earlier also, and I've done it again. So when it is required to be redone, please don't struggle with it. Somebody who was talking about in the red one TATF of 0.61, is it now clear to you, beta? When will the TATF of TC come?
Understood, sir.
Okay.
Yes, sir, understood.
Okay. So you have to be very clear. TATF of what? To the height draft, if it is initial height draft, it will be TATF of initial trim. If it is final height draft, it will be TATF of final trim. If it is height draft at critical instant, it will be TATF of trim that time. If it is height draft at any other moment, it will be TATF of the trim at that particular time. But when it comes to allowing changes to the forward and aft draft, it is TATF of the trim cost. Am I clear? Because then you are applying the changes. You applied the change in draft through mean rise, and you applied the change in draft due to trim by TATF of the trim cost. Understood, guys? Clear?
Yes, sir.
Okay, I'll take you through the solution. You know it now. There is nothing much to explain here now. Declivity is so much. Trim change at critical instant is 0.61 meters by head. This you already know, you've already calculated it, so I don't want to waste time. At critical instant, P is 117. W minus P will be so much. And now we can have the GM calculation. And GM comes to 0.244. I'm sure this all of you have done, so there's nothing much. Then calculation of draft, you can do it either way. I have done it the first way. So the high draft will be 4.836 at critical instant. Trim at critical instant is 0.45 meters by stern. That is due to declivity of the dock. TA will be so much, TF will be so much, and the drafts would be so much. Correct, beta? Am I right?
Yes, sir.
If somebody is getting the draft other way, it's also okay, no problem. That's up to you which one you want to use. So guys, through this question, what have I tried introducing? How to factor in declivity and how to handle a question where the particulars are fixed. And I'm sure you'll agree that if you happen to get a fixed particular question in the exam, you should consider yourself fortunate because that relieves you of hassles of interpolating the hydrostatic particulars, right?
Yes, sir.
Now, what is the time now, guys?
12, 12, sir.
12:10. Okay. Can you please take down this question and tomorrow come with the answer to this question? It's a trim question, nothing to do with dry dock. Don't confuse yourself. MV hinge ship is floating in seawater with a displacement of so much, kg so much, LCG so much, FSM so much. Calculate her drafts forward and aft. So what will you do? You'll get the height draft for 9788. You'll calculate the trim. You'll split the trim into TATF and you will basically apply and get the drafts forward and aft. So you'll be calculating the trim and then you'll be calculating the forward aft drafts. Guys, it's a simple trim problem. Would you be able to do it? I'm giving you with a purpose. It's not out of context. But this will also help you in revising your MV hinge ship trim problems, right? At least the basic part of it. So please do it. Tomorrow I'll be asking you the results of it and then we'll continue. So tomorrow we'll first finish the trim questions, complete the trim issue. And once we finish the trim issues, we'll move on to grounding. Again, what should you do? Maybe a question in your minds. Should you start testing yourself by doing questions from past papers? Don't bother right now. Right now, you have these 6-7 questions that we have done. These 6-7 questions you must understand and should be completely convinced that you have understood the questions and you are able to solve. Second is complete this question and get the trick. Okay. Tomorrow and day after tomorrow. Day after tomorrow means the next class. If it is Monday, it's fine. If it is some other day, okay. So whenever we have the next class. So when we have the next class, I'll basically be taking you through in next 2 sessions through grounding. So hopefully in next 2 classes, we'll finish with dry docking and grounding. Then I'll give you some assignments from the past MMD papers. You'll solve them and you'll get back to the class with the doubts. Okay, so that is what the process would be. We'll start with the new topic, Simpson's rules. But in the meantime, you'll be doing dry docking and grounding questions and you will come back to the class with your doubts so that we have another almost, guys, we'll be connected for almost another 15-20 days from here on, and that is good enough period for everybody to be comfortable with dry docking and grounding and have your doubts discussed in the class. So that is the whole idea, that this topic should be finished upfront so that people have time to get back with their doubts. Okay, beta? Okay, class?
Okay, sir.
Okay, guys. See you tomorrow, 9:30 then. Okay, bye, beta. Bye, bacha. Bye, guys.
Bye, sir. Thank you.
Bye. Thanks.